Hi friends, if you watch this whole video, you'll find the topic real easy. The topic will seem natural to you. So what's the topic for today? That's right, this video is about numbers. In this video, we'll explore the different type of real numbers such as natural numbers, whole numbers, integers, rational and irrational numbers. And then we'll finish off with our top 3 test-oriented questions on this topic. Let's go back to the kindergarten days and start with counting numbers. Remember the rhyme? 1, 2, 3, 4, 5, once I caught a fish alive. Well, these numbers such as 1, 2, 3 and so on are called natural numbers and they are denoted by the letter N. Let's draw a circle to represent the set of natural numbers. Now, whole numbers includes all the natural numbers and 0. So we can draw the whole number circle around the natural numbers. Integers include all the whole numbers and negative numbers such as -1, -2, -3 and so on. So we can draw the integer circle around the whole numbers. One important thing for you to keep in mind is that 0 is considered neither positive nor negative. Let's place the diagram we just did on our concept board. Now the question is, are there any numbers between any two integers? Let's say between 0 and 1. Yes, and we use them all the time. For example, half, 1/3, 0.7, 0.8. So between any two integers, you have these non-integer numbers, which are known as fractions or decimals. And this entire set of integers and fractions and decimals are called rational numbers, and they are denoted by the letter Q. Any rational number can be written as a fraction, P by Q, where P and Q are integers. The only restriction is that Q should not be 0, since division by 0 is undefined. Now, is the natural number 3 also a rational number? What do you think? So 3 can be written as 3 by 1. It can be written as a fraction in a P by Q form. So 3 is also a rational number. Now what about 2.5? So we can write it as 25 by 10. And if you simplify the fraction, you get 5 by 2. So 2.5 is also a rational number. So any rational number can be expressed in a P by Q form. That is in this fraction form. The only restriction is Q should not be equal to 0. And typically P and Q don't have any common factor except 1. So we write the fraction in its simplified form. Let's add the non-integers to our set diagram. The integers and non-integers, that is fractions and decimals, together are called rational numbers. Let's talk more about rational numbers that are not integers. As we learned, rational numbers are fractions, represented by the P by Q form. You can calculate the fraction by dividing, and we end up with a decimal number. For example, 7 by 10 is 0.7, 5 by 2 is 2.5, 7 by 4 is 1.75. These are all examples of terminating decimal numbers. That is, the decimal digits stop or terminate after a point. Because on dividing by the denominator, the remainder is 0. But there are other fractions which on dividing don't terminate. For example, 2 by 3 is 0.6666 and it just goes on. So we write it as 0.6 with a dot or a line on top to represent that the digit 6 is recurring, which means repeating. Let's take another example, 1 by 7. So if you look at the answer here, can you see the repeating pattern? That's right, it's 0.142857 recurring. Let's take a look at another example, 1 by 6. So that's going to be 0.16666 and it just keeps repeating. But notice that we write it with a dot or a bar only on top of 6 because only the 6 is repeating. So these are called recurring decimal numbers, where on dividing by the denominator, the remainder is never 0 and the digits in the quotient keep repeating. If you take any fraction, how do you determine that on division you're going to get a terminating decimal number or a recurring decimal number? Of course, one simple way is to actually do the division. But there's another trick where you don't need to divide. Now what's the trick? You need to take a look at the denominator. And if the denominator has factors of 2 and 5 only, then you're going to get a terminating decimal number. Otherwise, it's going to be a recurring decimal number. Let me pull up some examples to illustrate this. Let's start with the example of 7 by 4. Now, what are the factors of the denominator 4? It's 2 into 2. Now, our goal is to convert the denominator into multiples of tens. So, I'm going to multiply 5 into 5 in the numerator and in the denominator. So, I get 175 by 100. That's 1.75. So, this is a terminating decimal number. But if we take 37 by 150, so what are the factors of the denominator? They are 2 into 3 into 5 into 5. And if you divide, we get 0.24666 and so on. So this is a recurring decimal number. And why is that? Because if you carefully look at the factors in the denominator, you can see that there's a 3 there. For it to be a terminating decimal number, you need factors of 2 and 5 only. Now a rational question is, are there numbers that are not rational? The answer is yes. These are called irrational numbers. For example, root 2, root 3, cube root of 10, these are all irrational numbers. But we'll look at these in a separate video. Let's try to place the different numbers that we've learnt on a number line. Are you familiar with a number line? An everyday example is a ruler or a measuring tape like this with numbers marked on it. Unlike the measuring tape, the number line has both positive and negative numbers. So let's draw a number line and try to place the different numbers on it. So here's our number line. Let's mark the natural numbers on it. 1, 2, 3 and so on. Let's draw another number line and mark the whole numbers on it. So it's going to be the natural numbers and 0. In our third number line, let's mark the integers. So it's going to be all the whole numbers and the negative numbers, -1, -2, -3 and so on. In the next number line, let's mark the rational numbers. So it's going to be all the integers and decimals and fractions. For example, 1.5 is here midway between 1 and 2. 2.8 is here and it's closer to 3. And -half is midway between 0 and -1. We can also visualize the number system by starting from the top, that is, from the real numbers. Let me pull up the concept board for you. Real numbers can be divided into rational and irrational numbers. Rational numbers can be divided into integers and non-integers. Now, integers can be divided into negative integers and whole numbers. whole numbers can be split into 0 and positive integers, which are natural numbers. Coming back to the non-integers, fractions and decimals. These can be divided into terminating decimals and non-terminating or recurring decimals. Now let's say you want to find rational numbers between any two given rational numbers. For example, between 3 and 5. One simple answer is 4. We can get it by finding the average, 3 plus 5 by 2, which is equal to 4. If you want to find more rational numbers, then you can do 3 plus 4 by 2. That's 3.5. And 4 plus 5 by 2, which is 4.5. Now let me pull up some more interesting examples for you. If we want to find two rational numbers between two fractions, for example 1 by 7 and 4 by 7, since the denominators here are equal and the numerators have a gap, we can fill in the fractions in the gap. So our answer is going to be 2 by 7 and 3 by 7. But what if there's no gap? For example, if we have to find two rational numbers between 1 by 7 and 2 by 7, then what do? We can create a gap by multiplying the numerator and denominator with a number. Since we need two rational numbers, we will multiply by 2 plus 1, which is 3. Multiplying the numerator and denominator of the two fractions by 3, we get 3 by 21 and 6 by 21. Again, the denominators are the same. But can you see that we've got a gap in the numerator? So the two fractions we can insert are 4 by 21 and 5 by 21. Now let's look at the case where the denominators of the two fractions are not the same. For example, if we want to insert 6 rational numbers between half and 2/3, as you can see, the denominators are not equal. So the first step is to make the denominators equal. So our two fractions become 3 by 6 and 4 by 6. Similar to our previous case, now the two denominators are equal, but there is no gap in the numerators. So what should we do? That's right, we need to multiply by a number. And since we need to insert 6 rational numbers, our number is going to be 6 plus 1, which is 7. So let's multiply the numerator and denominator of the two fractions by 7. So here we have 21 by 42 and 28 by 42. So here are the 6 rational numbers that we can insert between these two fractions. And on simplifying, the 6 rational numbers, and that's our answer. Let's talk about fractions and decimals. How to convert fractions to decimals and decimals to fractions. Converting fractions to decimals is easy. You just need to divide. For example, 3 by 4 is 0.75, a terminating decimal number. 1 by 3 is 0.333, recurring, a recurring decimal number. Now if you want to convert 0.75 to a fraction, then we can write it as 75 by 100. Simplifying, we get 3 by 4. So these are simple. But a more interesting question is, how do you convert a recurring decimal number to a fraction? For example, 0.333 recurring. Now we know that 0.3 is 3 by 10. 0.33 is 33 by 100. 0.333 is 333 by 1000. But we are looking for 0.3333 recurring. So let me show you the technique how to convert a recurring decimal number to a fraction, coming up for you right now. Let x be the recurring decimal number. which is 0.3 recurring in this case. So let's write it as x equal to 0.3333 and so on. Now we need another number where the part after the decimal is the same. So let's multiply x by 10 and we have 10x equal to 3.333 and so on. So as you can see here, x and 10x have the same part after the decimal. Now let's subtract x from 10x. So I'm going to copy the first line here. On subtracting, we get 9x equal to 3. So x is 3 by 9, and if we simplify, we get 1 by 3. So we have converted our recurring decimal number 0.3 recurring to a fraction 1 by 3. Let's look at another example. Again, let x be the recurring decimal number, which is 1.27 recurring. To find another number with the decimal part matching, this time we can't multiply by 10. We need to multiply by 100. And as you can see, in 100x, the decimal part matches. So once again, subtracting x from 100x, we get 99x equal to 126. And on simplifying, we get 14 by 11. So we've converted our recurring decimal number to a fraction. Now that we are done with the topic of rational numbers, let's take a look at the top 3 questions on this topic, coming up for you right now. I would like you to pause the video right here and try solving these questions. Let's make this more interactive than just watching the video. So do post your answers in the comments below. Or if you have any doubts, questions, feel free to write it in the comments below. And I'm going to make a commitment to answer all of them promptly. So I'm going to move off and let you solve these questions. Thanks for watching the whole video. I hope the number system is real easy for you now, and the numbers seem more rational and natural to you. All puns intended in that sentence. And do remember